Hello and welcome to this video. In this video we will be discussing about linked list. Talking about linked list, the first thing that comes to my mind is why linked list and why not arrays. Let's see with the help of an example. Let's say we want to store some values but we don't know how many values we have to store. So let's say we declared an array of size 100. So what happens is a contiguous block of memory is allocated and that block of memory is divided into 100 parts and each part will store one value. So let's say we want to store 2, 3, 4, 5 and 6. So if we declare a block of size 100, the block of size 100 will be divided into 100 parts and each part will store one value. So the first part will store 2, the second block will store 3 and then 4 and 5 and 6 and so on. So the rest part of the memory which is allocated is getting wasted. So to prevent this we use linked list. So what happens in a linked list? Let's take the same example. We want to store the same values 2, 3, 4, 5 and 6. So if I want to store these values using linked list, then 5 blocks will be allocated and let's say this one will store 2 and one more block, this block will store 3, one more block and this block will store 4, another block will store 5 and the last block stores 6. Now as in the case of arrays, these memory blocks are actually not contiguous blocks of memory. So from the first block you have to somehow identify the location of the next block and from the next block you again have to get the location of the next block. So for doing that, a pointer to the next node is also stored. So with the data, a pointer to the next node is stored in every block. So here as well, a pointer to the next node. Same is the case with this one and same is the case with this one. Now since each and every block is not a contiguous block, so you have to get the head block. This is actually called the head of the linked list. You have to store the location of the head block of the linked list in order to traverse the linked list. So once you have the head of the linked list, then you can use these pointers to actually traverse the linked list. And for the last node, this is actually called the tail of the linked list and this will actually point to null. Now each and every block of this linked list is called a node. So each and every block is called a node. So each node contains 2 blocks. The first block will contain the data. It can be any data, maybe integer, string or maybe a complex object as well. And the second block will point to the next node. So the advantage of doing this is that you can dynamically allocate memory and you can add more blocks of memory after 6. If you want to add, you can add more blocks of memory, and you can even insert another block in between these blocks of memory. In case of arrays, if you want to insert in between, then you have to actually shift these values by one index and then you have to insert. But in case of linked list, you just need to have the head node and you can traverse and you can easily insert a new node in between the nodes, in between two existing nodes, very easily just by changing the pointers. So I hope you got what is actually linked list and why we use it. So in the next video I will be implementing linked list and its various use cases as well. So thanks for watching.